Okay.
Can
So
start?
hang on. Let me just introduce you first. So, Assalamualaikum and good afternoon, everyone. So today, just like the week before, we're going to have 3 presenters. So we need to have you present on time. So remember, there are only about 25 minutes of presentation, and the other 5 minutes should be on Q&A. For the first presenter is Abdulkader Mohammed, MFA, okay, and he will be talking on effect of hydroxyapatite addition into glass ionomer cement derived from soda lime silica glass and clamshell waste with different ratios of water and aging times. So can go ahead now.
Okay. Assalamu alaikum and good afternoon for Dr. Hisham and all sir and all students. My name is Abdulkader Muhammad Aifa. I am a PhD student. My title is Effect of Hydroxyapatite Addition into Glass Ionomer Cement derived from soda lime silica cell glass and the clamshell waste material with different ratio of water and aging time. My supervisor is Dr. Cameron and Dr. Chi Azor and Dr. Noor Hazali. This is my outline, introduction, problem statement, research aim, literature review, and materials and method, expect result and references. Introduction. Biomaterials are referred to as biological materials that have replaced any defective part of the human body, such as cell tissue, organs, and body function. Biomaterial consists of glass, ceramic, and
Excuse me.
Mm-hmm.
Have you moved to the other slides? Because we are seeing the same slide.
No, next to other slide. No.
You have not started
No.
the other slide.
No.
No, we are seeing the same slides.
Here. No. The same slide.
It's the same slide. Is
Okay.
there somebody with you that can help? Okay, now we have.
No. No.
Yeah, okay, we have seen it.
Okay, Doctor. Thank you. Bioglass describe a group of surface reactive glass ceramic biomaterial. These products are bioactive and biocompatible and are used in the repairing of bone in the human body which are broken or diseased. Bioactive glass are bioceramic that are solid, non-porous, and hard material, which consist of the human component of silicon dioxide and 3 others basic components, sodium dioxide and calcium oxide and phosphorus. For glass ionomer cement, glass ionomer cement is primarily used in the prevention of dental caries. That this dental material has good adhesive bond properties to teeth structure, allowing it to form a tie seal between the internal structures of the tooth and the surrounding environment. Glass ionomer cement are based on the reaction of silicate glass powder and polyacrylic acid. This reaction produce a powdered cement of glass particles surrounded by matrix of fluoride elements, and it is known chemically as polycarbonate. Problem statement. In recent years, the glass and the glass ceramic have widely attracted interest in the medical applications due to their properties toward the biological reaction. The cost of production of biomedical material, especially in dentistry, is high increased due to the cost of raw materials. The use of clamshell and SLS waste material in the fabrication of calcium aluminum fluorosilicate glass can reduce the cost of production biomedical material. Despite it having many advantages, there is limited research on mechanical properties of GIC, such as low fracture, low strength and toughness, weak wear resistance, with limited their uses in the dentistry application. The synthesis and investigations of calcium aluminum fluorosilicate based glass ceramic from waste material are still limited in industrial research. Objective of this research after synthesis calcium fluoride fluoroaluminum silicate. We will study the effect of centering temperature on the physical and mechanical properties of glass, and also to determine the suitable ratio of hydroxyapatite addition, and also to analyze the effect of agent time on the glass ionomer cement properties. So for research lecture review, because of GIC properties like biological reaction, nowadays has become a significant area to research. At present, manufacturers' cost for medical applications, especially in industry, is quite rising over the year due to the increase of production. Include to the calcium oxide. SLS or sodium silicate glass, it has the SiO4 silicate tetrahedral acts like the glass system's main framework. The silica tetrahedral plays an important role in network formation. The oxide, a pure silica oxide, or known as silica, has a high melting point, which is at around 1,700 degrees Celsius due to the high strength of the Si bond. The high melting point of pure silica can be reduced by adding the sodium oxide network, which is act as a network modifier in the glass system. By comparing pure silica and SLS glass, the SLS glass has low melting temperatures around 1,000 degrees Celsius. For the clamshell in the last years, clamshell is widely used as a source of the calcium oxide beside element in various industries due to its low cost consumption. The clamshell is one of the natural sources which is rich of calcium carbonate, so it can get calcium oxide easily by using calcium clamshell. Hydroxyapatite. The incorporation of hydroxyapatite particle with different size and composition enhanced strength and microstructure properties of GIC. So an optimum amount of nano-sized hydroxyapatite added into the GIC resulted in higher compressive strength than micro hydroxyapatite. Agent time of GIC is a phase of GIC after the gelation phase. During this stage, the GIC will be experienced complex chemical reaction and improve physical and mechanical properties. For methodology, for making glass calcium aluminum fluorosilicate, we will use this formula. It has contained calcium oxide and aluminum oxide and calcium fluoride and phosphor oxide with the different ratios of component. To preparation raw material, first we start with Sls. After clean and dry the bottle, the bottle will crushed and will crushed by use a plunger and grind it and save it to get powder sized by 45 micrometer. For clamshell, after cleaning the clamshell and drying, the clamshell will be calcined on the furnace in 900 degrees Celsius. After that, we'll plunger and grind and save to get fine powder. To fabrication glass, after waiting all raw material and the other composition, the mixture will be put in the milling jar to make it the homogeneous mixture. After that, we'll put on the furnace for 1500 degrees Celsius for melting for 3 hours. After that, after melting, the melting will quench it in water to get glass frets. The glass frets will be centered for different temperature 600, 700, 800, and 900. After that, crush it and save it to get a fine powder. For addition, hydroxyapatite, this formula will be used for addition hydroxyapatite by a little bit ratio, start from 0 until 0.1 weight percent. For fabrication glass ionomer cement, the glass powder will mix with polyacrylic acid and with the deionized water by using the ratio of 3:1:1 for glass and polyacrylic acid and water, and also 3:1:1.2 for the water, and 3:1:1.4 also for the water. After mixing well, the mixture will be put on the mold, the stainless steel mold. After that, dried on the 37 degrees Celsius for 1 hour. After that, we'll get a small billet. Small billet, this will be divided in five bottle and immersed in deionized water for 1 day and 7 days until 28 days. For analysis, XRF will be used to determine the chemical analysis material and composition of elements. XRD to identify a specific material, which is crystal or amorphous. FESIM to determine the surface morphology and the microstructure of the sample. FTIR to identify the presence of functional group. The other mechanical properties, we will use Vickers hardness to determine the degree of hardness and also compressible strength to measure the maximum strength. Result and discussion. First, the result of XRF for SLS, the element composition of SLS glass, it has silicon oxide is the dominant element, is around 63 weight percent, followed by calcium, sodium, and calcium. For the XRD pattern of SLS glass shows the broad ham characteristic, the highest 2 theta peak of the broad ham at around 25 degree. This is provide the SLS glass consists of non-crystalline phase and exists as a glass structure. For the clamshell, this result for raw material, and this for carbonide. For raw material, the obtain the major element composition in raw material is calcium, while the rest are other trace elements such as Fe, Cu, Sc, and Sr, and Cu. The amount of calcium indicate around 88 W weight percent. For the XRT for raw clamshell and calcinide clamshell, the crystalline phase of calcium carbonate between 10 to 90 degree of 2 theta. This result confirmed that the raw clamshell consists of calcium carbonate as a single major crystal phase. The crystalline phase of calcium carbonate is made up of two different crystal systems known as argonite and calcite. For XRD analysis for calcium aluminum fluorosilicate glass, the glass centered for different temperature, start with 600 until 800. The XRD shows the pattern of calcium aluminum fluorosilicate based glass ceramic with the different centering temperatures. The glass before centering shows the presence of fluoroapatite phase in the sample. As the centering temperature rise to 700 degrees Celsius, the peak of fluoroapatite phase become the major phase in the glass composition. However, the fluoroapatite phase start to decompose or convert into new phases at 800 and 900, which is molite and anurite. The density of glass built centered at room temperature until 900 degrees Celsius are shown in this figure. The density of the sample has increased from 2.222 at room temperature until 2.76 gram per centimeter cubic at 9 degrees Celsius. The glass pellet become significant at 900 degree. This situation happened because the particle underwent sintering, as well as the development of green growth in the sample. Then the particles packing in the unit volume increased, and it can enhance the particle contact for crystallization. The molar volume of the sample shows a different trend with the density, where the value of the molar volume palette has decreased, start from around 37 at room temperature until 30 at 900 degrees Celsius. For the mechanical properties, the thicker microhardness represent the hardness of the surface against the identer with a diamond shaped. The GIC surface hardness was tested by the Picker's hardness method with different sintering of calcium fluoride aluminum silicate glass. Every ratio of the glass sample is varied with aging time from 1 to 28 days. The average of Vickers hardness of GIC with different centered show the Vickers micro hardness of GIC is increased to the aging time for all pitch. However, the ratio of glass powder and polyacrylic acid (PAA) in the weight percentage during fabrication of glass ionomer cement is fixed at 3 for powder and 1 for polyacrylic acid. In the glass system, the calcium compound act as a nucleate agent, and a high amount of calcium compound will be tend the glass to crystallize the fluoroapatite crystal. Thus, the crystalline phase of fluoroapatite in the glass system can improve the GIC hardness. For compressive strength, this figure present compressive strength test for GIC throughout various aging time and sintering temperature. The compressive strength value of GIC to sintering temperature shows an increased trend from lower temperature until 700 degrees Celsius. Then the compressive strength value decrease starting at 900. The GIC obtained highest compressive strength value at 700, which is 21 megapascal at 28 days of aging time. In contrast, lowest compressive strength value were obtained at high centric temperature at 900 degrees Celsius, which is 3 megapascal for 1 day of aging time. For aging time, the enhancement of compressive strength value on the GIC due to high degree of crystalline phase in the GIC. Basically, crystalline phase consists of high ordered arrangement with the develop denser structure in the glass system. So the conclusion: fluoroapatite increase with the increase heat treatment. Also, the density will increase would also increase the heat treatment. The high value for vehicle hardness and compressive strength, it was on the 700 degree Celsius. This is my Gantt chart, and this is my references, and thank you for listening this far.
Okay, thank you, Abdulkader. Welcome. Any questions from your peers?
Yes, Prof. I have a few questions for him.
Okay, go ahead.
Okay, I'm Zui. Abdulkader, can I ask, like just now you got mentioned about you will do aging time, like immerse your GIC in deionized water, right? So may I know, like if you increase when you put your sample, your GIC in the deionized water for 7 to 28 days, so how does this will affect your properties of your GIC?
Okay, thank you, Zoe. Yes, because the initial ratio of water during the fabrication of GIC is essential because it can enhance the mechanical properties itself, especially in setting time. So during the early stage of a GIC setting time, water surface at the medium for reaction. The part of the setting process include further cross-linking of polyacrylic acid etching by metallic ion such as calcium oxide ion and aluminum oxide. So by carry this ion, I mean the water will be play as a medium to carry this ion to create fluoroapatite phase and other phases. So, thank you.
Oh, okay. Sorry, one more question.
Okay.
Because like from previous study, like what I studied, like for GIC, normally they will just direct use the glass and make it to become the GIC. But you are doing the sintering process. So like what I know is like sintering process will affect the bioactivity. So what is the purpose of you doing sintering process then after doing for the GIC?
Yes. Okay. Because a glass system consists of silicon oxide, calcium oxide, aluminum oxide, also calcium fluoride, and so on. So the toughness and the strength for this composition will be can I say will be good after convert into ceramic. This is related to the microstructure of interlock, apatite, and molite crystalline. And the calcium fluoro aluminum silicate glass system. So by sintering, will be appear fluoroapatite phase more and more. So fluoroapatite phase is responsible for the hardness like compressive strength and micro hardness. So that's the purpose of using sintering treatment. Thank you, Zoe.
Okay, thank you for your answer.
Thank you so much.
Okay, any other question from?
Hi, I'm women.
Okay.
So I have another one question. So just now I see your methodology. You are adding the HA into your glass system. So may I know why you want to adding the HA?
Yes, good question. Yes, thank you, Mohammed. Because the formation of apatite phase is one of the advantages in the dental application, because it is similar to the hardness of animal and compatible. Furthermore, the apatite phase also has the capacity to bond chemically to bond with the GIC. So we need to get the apatite phase. So we can get fluoroapatite phase by using hydroxyapatite. So that's why we use hydroxyapatite for this section. Okay.
Okay, thank you.
Okay, thank you. So,
Okay, I think time is running out.
I have a question to Mr. Abdulkader.
Okay,
yes,
go
okay.
ahead.
Mr. Abdulkader, can change to slide 21st, please?
This.
You mentioned about the Vickers hardness. Why the value of Vickers hardness is decreasing after 700 degrees Celsius?
Can you share the slide, please?
Share, sorry. Okay. Yes, this. Mr. Ali,
Slide
this
21st. Yeah.
21, yes.
21st.
Uh-huh.
Yeah. This
Okay.
one. You mentioned about the Vickers hardness. Why the value is decreasing after 700 degrees Celsius?
Yes. Because the mechanical properties of the glass ceramic are related to the fluoroapatite content. The higher of the fluoroapatite content is around 700 degree. So after 700 degree, there is another phases will be appear like molite and anarite. So during this convert from fluoroapatite to another phase. So there is can say some bond or cross linking will be weak than the previous. So the Vickers hardness will be decrease after 700 degrees Celsius.
Okay.
Thank you.
I have one question, please.
Okay.
What is the benefit for addition the calcium fluoride for your work?
Yes, because calcium fluoride, one of the purpose to get a fluoroapatite phase. So fluoroapatite is responsible for hardness and compressive strength, and the other purpose because calcium fluoride, because the glass calcium fluoride in the glass will be release fluoride ion. This ion, it can be enhanced the animal characteristic in the oral caries problem for teeth.
Okay, thank you, sir.
Thank you.
Thank you, sir.
Okay, I think we should proceed to the next presenter. Zarina binti Ramli. She's doing a proposal presentation. So she will be speaking on radiomics analysis and machine learning model for classification of cervical cancer DWI-MRI images. Please proceed.
Okay, Prof. Okay, Assalamualaikum and good afternoon to all Proshamudin and to all my colleagues. Today I would like to present my seminar research proposal with title of Radiomic Analysis and Machine Learning Model for Classification of Cervical Cancer, DWI-MRI Images. My name is Zarina binti Ramli with my metric number GS63761, PhD in Medical Imaging under Faculty of Science and supervisor with Dr. Muhammad Khalish bin Abdul Karim and my co-supervisor Dr. Muhammad Amiruddin bin Abdul Rahman. This is the outline of my research presentation. I will briefly about my problem statement, objective, hypothesis, my research method, my expected result, and the Gantt chart. As for introduction, first of all, I would like to give a big introduction about the cancer. The cancer is the second leading cause of death globally and contribute to 9.6 million deaths in 2018 by WHO. In Malaysia, cervical cancer is the fourth most common cancer incident, as stated in the Malaysian National Cancer Registry Report 2019. And according to the incident rate for 10 most common cancer in Malaysia from 2012 to 2016, the cervix uteri was reduced to 6.2 compared to 2007 to 2011, which is 7.6. In the both report, 76% of the cases are still diagnosed at the late stage of the cancer, which is on the stage of 2, 3, and 4. And for age incident rate, the trend of incident in 2012 to 2016 is similar to 2007 to 2011, with the highest incident at the age of group of 70 to 74 years old. However, it's reduced the incident rate is seen in all age group in 2012 to 2016. And the death from the cervical cancer are rare among the young women, but incident increased from the age of 30 to and it peaked to 70 to 74 years old. In the field of the medical imaging, there are wide region variation that used in the workup of the cervical cancer. In my research, I will use MRI modality because MRI provide excellent soft tissue contrast that allow accurate assessment of tumor infiltration, the size, the location, and their staging. This according to DEPA et al. 2017. And the new advancement MRI technique allow the improvement analysis of tumor biology and also the tumor microenvironment, and improve on the TNA staging, which is the staging for the cancer. They show the promise for the tumor classification and assessing the risk of tumor recurrence, and also helpful to develop the optimized and personal therapy for patients with cervical cancer. This is the images of the MRI 3 Tesla that I used at the IKM Putrajaya. And this is how patient will position during the MRI of the MRI cervix to evaluate the cervical cancer. And this is the localizer that used to plan for the cervix area, which is we can see on the sagittal, axial, and the coronal view. The DWI-MRI, why we choose for the Radiomics feature of the DWI-MRI? Because the diffusion images of the MRI is based on the principle of the Brownian movement of water molecule, and it gives information about the tissue structure on the microscopic level and improve the tumor delineation and detection of nodule metastasis in the cervical cancer. So the tumor apparent in the ADC, which is the diffusion coefficient, in images of the DWI-MRI can be as potential biomarker for response to the treatment due to its higher intense signal of tissue cellularity, and is used in the development of individual regime based on the ADC parametric. And briefly, the primary and secondary study endpoint in the drug also validate that via the complement of the existing morphological and functional imaging method. And this ADC allow for easy visualize of assessment, measure for the water molecule, and reflects the biological changes in the tumor microenvironment before and after patient receive the treatment for the cancer. For the radiomic method overview, the image will be segmented with the performance of the DWI-MRI images, and we will contour the tumor area on the DWI images with planning software. In my research, I will use the 3D slicer platform, and the features are extracted within the defined tumor contour on the DWI-MRI and quantify the tumor intensity, the shape, the the texture of the GLCM, GLLRM, and NGTDM. For the problem statement, the random sampling biopsy that used in the current now has the for the surgery for diagnosis have limitation because it will including the procedure related complication such as the sampling error, the intra-observer variety on the post-procedure related complication to the patient. Therefore, the intra-observer variability, the false negative diagnosis is also unavoided as a human error will also influence the diagnosis and prognosis to the patient. Most of the tumors show unclear border which impact on the image segmentation and reproducibility issue. Some features may show stability and reproducibility using one segmentation method, but not another's images. And routine clinical imaging show wide variation in acquisition of the parameter, which is result in the different value of the radiomics features, the image noise, and the texture of the radiomics. Thus, we need to identify and exclude the unstable features from the acquisition and reconstruction back all the parameter. And with the machine learning technique as a tool that lead to the selection of appropriate feature selection and to develop the classification of the cervical cancer staging. The significant indices to standardize in the clinical imaging protocol in the assessment of effectiveness of the cancer treatment and to establish the radiomics index based on patient survival and cancer staging to predict the patient survival to determine either more intensive observation or aggressive treatment that needed or should be administered to the patient. And the benefit for our population in Malaysia, it will decrease the mortality rate and improve health service, especially in the cancer treatment, thus to evaluate the patient quality of life. The need of the research in understanding in the MRI at the DWI images at the microscopic level in the standardized on the clinical imaging protocol is crucial to assist in the assessment of the effectiveness of the cancer treatment. This is objective that used in my study. The general objective to develop a radiomic score and machine learning model to classify of the cervical cancer DWI-MRI images. And the specific objectives to evaluate the reproducibility and radiomic features of the cervical cancer, evaluate the decision model between cervical cancer of the images DWI-MRI and the images of the T1 post-contrast, and to determine either optimized feature selection for radiomic analysis in classified the diagnosis of the cervical cancer staging. And finally, to develop the machine learning model based on support vector machine for the classification of the cervical cancer based on the DWI-MRI images. The hypothesis in the study to radiomics features from DWI-MRIs will provide the classification of the cancer staging for better understanding of patient treatment planning, the response to the anti-cancer therapy, the drug development, and the cervical cancer rate survival. The methodology in my study. This is a retrospective study that we conducted at the Institute Cancer Negara Putrajaya over data of the previous data, 5 years period of data. And the patient with the confirmed early stage cervical cancer who fulfill the inclusion and exclusion criteria will be recruited. The inclusion criteria that patient with the confirmed pathological cervical cancer and patient have underwent contrast MRI previous before do the surgery and has been done the protocol for the MRI previous, including the sequence of the DWI-MRI, and patient that has underwent for the planning of the radical hysterectomy and bilateral pelvic limb knot dissection. And for the exclusion criteria, where patient was not included in the study if they have incomplete information regarding MRI pre-treatment imaging and no HPE result, or patient has been treated with the radiotherapy of the preoperative or neoadjuvant chemotherapy, because it will affect the outcome of the radiomics features if patient have already treated with the radiotherapy. And patient has been diagnosed with the metastasis cancer also will be excluded in this study. After the inclusion and exclusion criteria and all the demographic information, the pathological tests and preterm MRI imaging data were collected, the images will be segmented and the features will be extracted to evaluate for the model building and to get the Radiomics index that will go to the comparison with their clinical outcome. For the expected result, the DWI-MRI and sequence of the post-contrast T1 axial cervix will be segmented during with the 3D slices platform, which is 3D slices version 4.11, and the region of the features will be extracted into the tumor intensity, the shape, the texture for the analysis, and the group of the features and the Cox regression model for assessing will simultaneously with the relationship between multiple risk factor and the cancer staging will be evaluated. The example of the PEC images that will include in the study like this, the images from the PECs will be generated to get the image segmentation of the tumor, and the feature will be extracted based on their log intensity, the shape, their length, and the texture. And the features will be evaluated to get the model building for the hazard function and the disease-free survivors and for the prediction of the cancer classification. The feasibility in this study is based on the result from the lens.org. The feasibility on this research topic for publication will increase starting from the 2050 and until 2022 right now. And for the frontier in oncology, they were the top journal by publisher, and the field of the study cover most active institute for radiology is mostly GE Healthcare. And this is my Gantt chart that are used in my study, the project activity and my project milestone. And this is a list of reference that are used in my study. And for that, thank you for your attention.
Yeah, thank you, Zarina. And I invite questions from your peers. Nurin?
Sorry, I want to ask a question about your last objective. Can I see your last objective?
Okay. Right.
For the support vector machine,
yeah,
how many stages you're trying to classify?
As we know, the cancer classification they have the 4 staging, the stage 1, stage 2, stage 3, and stage 4. If the previous study showed that they can estimate to evaluate the late stage of the stage 2, 3, and 4, because most of the cancer was diagnosed at the late stage, so we cannot get the early stage of the images because it's very difficult. And also at the based on my experience at the IKN, most of the patients that come to our center was at the late stage. So I think in my research, we can get the more of the images or the features of the stage 2, 3, and 4 because it's very difficult to get for the stage 1 cancer features because limitation of the sample.
Okay, thank you.
Okay.
Okay, any more questions? Unziatang?
Okay, hello. Hello, Zarina.
Yeah.
May I know how you decide on, except for the criteria to choose the patient, right?
Criteria for choose the patient. Okay.
Just now you show the criteria to select the patient. And
yes.
Except for this criteria, you will meet the patient physically or you will just directly get the information from the institute?
Okay. At the IKN, we have the system of fully integrated between the medical of the patient data and for radiological. So I get all the information of the patient demographic data in the system because all the information already in the system. So I get the ethic to evaluate the patient information, and then from that, I will filter the patient based on my inclusion criteria.
Okay, understand. And may I know how many patients that you have choose in your research?
Based on the calculation of the sample size, because my study is based on the population of the data they have at the IKN. So based on the calculation, my sample size will need 100 of the patient data, 100 patient. But based on my previous statistic at the IKN, we have more than that. So I think based on my target sample population, 100 is good enough based on the calculation.
Okay, understand. Thank you for your answer.
Okay, thank you.
Okay, we still have some time. Are there any other questions from your peers? Anyone? Otherwise, let me ask just, so with respect to the usage of data, is there a what you call necessity of, no, you know, when you use data of patient use, so there'll be some ethical guidelines with respect to that?
Yes,
is there
Prof.
anything, yeah, could
Yes.
you elaborate on that a little bit?
Okay. Yes. Because we use the patient clinical data, we need to follow the ethical workflow. So the ethical workflow in my study, I already registered on the NMRI, which is the National Malaysia Institute for Register that you to get the eligible access of the data patient. So I already go through the process for the permission in the sense of to get permission from the head of the Institusi Cancer Negara, and also after that I need to present this proposal to the CRC of the IKN before to get the data, because they need to go through all my proposal to know how I will use this data and how much data that I need to get based on my sample size. So right now I already registered with the MRI and already sent my proposal to the head of the NMRI society for the approval. And after the approval, only after the approval, after that only can I can get the data from the institute and to start my research. Right now, I'm just in the stage of the get permission from them. So once I get the permission, after that, I will go to the data collection and data analysis.
All right, thank you. So, right. So if there are no other questions from your peers, so we could proceed to the next speaker. Adezuka, are you here?
I'm here. I'm here.
Right. Okay. Can you share your slides?
Okay.
So Adezuka will be presenting something on electrical and optical characterization of copper, zinc, tin selenide, quaternary metal, chalcogenide, thin film via thermal evaporation technique for photovoltaic application. Please go ahead.
Okay. Good afternoon, Dr. Isham Hamadin, and my pleasure to greet all my colleagues here. My name is Adezuka Yahaya. My tick number is GS63104, and my supervisor is Dr. Josephine. I'm here to present my seminar progress, which is on title Electrical and Optical Characterization of copper zinc tin selenide quaternary metal chalcogenide tin films for photovoltaic application.
Could you go to the presentation mode if possible?
Okay. Okay. All right. So this good afternoon. Hello?
We are still seeing the
it's not showing.
Well, it's not the presentation mode. Okay, I mean, just proceed. I think otherwise we'll.
Okay. So these are the outline of the presentation. The introduction have problem statement, objectives of study, problem statement. Okay, methodology, results and discussion, conclusion and references. The introduction, my compound says this Cdtsc is a quaternary chalcogenide P-type semiconductor material suitable for photovoltaic application. Despite its the energy band gap of 1.5 electron volts, it is suitable for thin film solar cell devices. Although the constituent element of Cdtsc element is heavy, but they are ethylene abundant, cheap, and non-toxic. So the compound has a high absorption coefficient, and this make it suitable for mass production and solar absorbing material. And it has so it has other applications like it's applicable aside the solar cell application. So it also has application on optoelectronic device, energy storage, and optical fibers. So the problem statement, these are some of the problem I propose. I'll be working also, sorry, so the problems I have on this research. The first one is conventional synthesis techniques for Cdtsc are costly and time consuming. And the second problem is that the current deposition techniques used is used in the fabricating Cdtsc is complicated. It's complicated equipment setup, and that the desired commercial efficiency limit for Cdtsc thin film is 33% and is not yet being achieved. From literature shortly quasi limit. So, and I have the solution to the problems that the subatomic technique is less costly, faster, and it's faster to prepare the sample. And after I obtain the sample for Cdtsc, so I'll use thermal evaporation techniques to do the fabrication. And this technique is have easy equipment setup. And that after that, I'll select a proper device structure for the thin film that may yield higher desired efficiency for the photovoltaic application. Here on my work, I have some the current methods that have been used to synthesize this compound. So you can see that I have pulse laser ablation, magnetron spotting, co-evaporation, hot injection method, coordination, solvent method, solid state method, and subatomic method. That apart from the subatomic method, the method I mentioned have some drawbacks, such as complicated apparatus setup, then some other expensive setup, expensive apparatus, and the subatomic method is choosing for the preparation of Cdtsc nanoparticle because it is simple equipment, catalyst-free growth. It's low cost, environmental friendly, and less hazardous. So then why thermal evaporation techniques for my material? Why thermal evaporation method? Why I choose thermal evaporation method for the fabrication of my material? So as I can see, we have other techniques that have been used to fabricate the Cdtsc. Then we have evaporative deposition, ion plating, pulse laser deposition, spotter deposition, and some of these materials, they have some complicated equipment setup, low quality thin film production. So for the thermal evaporation, it's easy. It has an easy equipment setup. It produces multiple layer high quality thin films, and the vacuum chamber can easily control the sample morphology. So the objectives of the study. So to synthesize Cdtsc nanoparticle using the thermal method. So you can see the machine for subthermal method. Also to fabricate the Cdtsc thin film using the thermal evaporation techniques. You can see the evaporation machine here. So then after I've done the fabrication, the next thing I will do is to do the characterization for the structural, optical, electrical properties of a material. So the next I'll now investigate the potential efficiency of Cdtsc material for possible thin film application in the solar cell devices. So these are the literature I consulted, work with. These are some of the literatures. So the methodology, that's the CDT synthesis by subthermal techniques. So this process, I weighed the selenium powder, I added selenium powder with ethylene diamine, and I stirred it for 2 hours so that the selenium powder can change the selenium ion. So after 2 hours, then I added the zinc, copper, and tin. Then with CTAP. The CTAP serves as a suffocant. So and I stayed for 1 hour to obtain a homogeneous solution. So then I now put it on Teflon. Then heated it for 200 up to 250 degrees for 24 hours. So after that, I centrifuge it so that I can get the precipitate for the material. I mean the powder, the desired powder. Then I now dry it for 24 hours. After that, I grounded it so that I can have very fine powder particles. Then after that, now I did the fabrication for this so the sample, so that I can have a thin film deposition where I put the sample after I measure the desired sample. I put it on the boat. So then I subject it to power supply. So then I put the vacuum chamber, so that the vacuum chamber helps to protect the oxidation, the sample from oxidation, that is the surrounding gas. Then after that, I control the pressure inside the chamber, so to digest the pressure up to -10 to the power -5 millivolts. After the desired pressure has been achieved, so I vaporize the I heat up the sample to vaporize the sample so that I can have the desired thin film on the substrate. So then after that, I did some characterization. I have all this characterization to do with the sample, X-ray to measure the crystal structure, the TGA for thermal stability. So I'm going to do the FPL for optical analysis. Then EV measurement for the impedance, the electric and elasticity, the AFM for topography measurement, UV is for absorbance, the energy band gap that I'll be say from a tau plot, the potential application that's for the efficiency test. So this is some of the result I obtained from the XRD analysis for the sample. You can see the peak will correspond to the values on the sample. So I have the reference code here. The crystal system is tetragonal. So there's no, from the peak here, there's no secondary phases present in the XRD spectra of the CDT sample. And this shows that the CDT form is at its peak of purity. So the crystallite size is 43.5 nanometer, lattice strain is 0.419, lattice parameter is 5.688, 5.688, and 11.3380 respectively. So after the XRD, and I also obtained result for ultraviolet visible spectroscope. So where I have obtained for transmittance for the 20 mg, for 30 mg deposition and 50 mg. So from the analysis from the graph here, you can see that the transmittance were from 20 mg has highest transmission as compared to 50 mg. That shows the higher the bigger the sample, the smaller the transmission. So then for the absorbance, so I also have a strong absorption of the visible light, and the energy band gap were tunnable. These findings are relevant to the size and morphology of the Cdtsc thin film, and of interest. That shows that it's good for solar cells and a photovoltaic application because of its high absorption value. So I did the energy band gap obtained using the tau plot. This is for direct allowed transition, which is the energy band gap is 2.15 electron volt. So then the other one is the energy band gap gotten from the same tau plot, but this time is for indirect allowed transition. So the energy band gap here is 1.88 electron volts. So conclusion, there were no secondary physics present in the XRD spectra of Cdtsc. This shows that the Cdtsc is a pure sample, and the vacuum tube prevented the Cdtsc sample from oxidation. This shows that the sample morphology was homogeneous and uniformly deposited uniformly deposited thin film filament. So the optical absorbance energy band gap was found to be 2.23 electron volts for direct allowed transition and 1.88 electron volts for indirect allowed transition. The intensity of the dispersion peaks increased gradually from the increase of the reaction temperature, indicating the improvement of the crystallinity. So as a future planning, I'm going to complete the remaining characterization as I mentioned on the slide. So these are the grand chart for the whole of my result of my work. So these are the references. So thank you for listening. Thank you very much.
Thank you, Adezuka. So I welcome questions from your peers. Questions, anyone?
Hello, Adezuka.
Yes, thank you.
Can you show me your UV graph? This one.
Okay.
Before the slide 16. Slide 16.
16?
Yeah.
Okay, this 16. Okay, 16.
That's,
sorry, 16. Okay.
Okay. Can you tell me what does the first peak means?
Pardon?
And what does the first peak means?
The peak? What are the?
Yeah.
Okay, the peak I use as I can see that the absorption of materials was obtained at 0.56, 0.5, close to 0.55. So that is the peak I used to calculate the absorption of the films, and that's why we have a very strong absorption for the material. Thank you.
Also, that is the absorption of the whole material, the Cdtsc thin film.
Absorption of yes.
Oh, okay. So that's all is the photoactive layer.
Okay, that is also the absorption of this the host material. Yes, that's the same thing. Yeah.
Okay. Understand.
Thank
you.
Yeah.
Other questions, please? Zarina?
Okay. Hi, Adezuka, Zarina here. I just would like to ask regarding your method.
Okay.
That you show before this, you will stir the stir for 1 hour to obtain the homogeneous solution. For the method of the stir in 1 hour, the previous one.
Is it this?
11, the slice. Okay. You mentioned that they stir for 1 hour to obtain a homogeneous solution, right?
Yes.
Okay. For the method of the stir, are you stir manually or you use the machine? Because for the 1 hour duration, are you stir is manually?
No. I use a machine. I use machine.
For 1 hour.
Yes. Yeah.
Okay. After 1 hour, they will. Are you sure that will homogeneous solution? Is there any research that say that 1 hour is enough for the homogeneous solution?
Yes. I have a theory. So I mean, literature for that 1 hour is enough for homogeneous to obtain a homogeneous solution. So then after that, you proceed and heat it up for 250 degrees for 24 hours, where I'll obtain a clear sample. So for precipitation. So then from there, I'll now dry it for 24 hours. Then I grounded the powder after the 24 hours, so that I can have a clear and a clean powder for deposition. Yeah.
Okay, so now that is based on the previous research study has been declared that our is good enough for homogeneous solution.
Yes.
Okay, thank you.
Thank you. Yeah.
Okay, we still have a fair bit of time. So any more questions from your peers? Otherwise, I will probably stop the recording now to end the session. So please do stay back to get your attendance. Okay. So I will stop the recording now. Thank you for all the presenters. So let me just stop the recording.
All right.